So I see maths as the last act, which means that it's the most important, right? Not that everybody that wanted to has exited out after having a couple of drinks. So usually when I'm in a pub and I'm saying I'm a mathematician, I get that stony silence from the person after me. And if I don't get that stony silence, what I get from people is, I hate maths. All right, and come on, all of you are imagining now that story of when you were 7 years old and that maths teacher who was rapping you over the knuckles or making you memorise your multiplication tables or shaming you or tapping into your deep phobias or anxieties, which means that, maths is scary. Where does this come from, that we are allowed the social license to say, I hate maths, especially to somebody that says, I'm a mathematician, right? I'm kind of used to it now, I've got thick skin. But, any other profession, just think of it. If I come up and say, I'm an architect, anybody say, I hate architecture, I hate buildings, right? And so let's have a look at mathematics. I'm spending my time, so in my day job, very happily teaching calculus and linear algebra, mostly to engineers and psychologists and other people. But my love is the history and philosophy of mathematics, which I actually didn't realise mathematics had a history and philosophy until I was at university for 4 years, so I've just saved you a bit of time. And I'd like to look at this, perhaps play upon our number phobia and look at the idea of what if mathematics just ghosted us. What is it about mathematics that we're telling everybody that it's so important, it underpins everything that we do and the like. So in my office at university, you can come in, you can sit down on a couch, you can look at the plants, you can see, actually you can't see in this picture, but there's some Rubik's Cubes to play with, and there's this board that says, could we live in a world without numbers? And usually it stops everybody and think, oh, goodness me. So suddenly that number phobia thinks to, actually numbers are pretty important and pretty useful. How do I use them in everyday life? And actually, what exactly are they? Are they actually real or not? And so the question gets risen to us is, what is it of numbers? Just like this question around money. Is it us that brings mathematics into being? Was there mathematics in the time of the dinosaurs? Did they know 2 + 2 = 4? Could we, mathematically model their populations? Or if they'd lasted long enough, would they too be doing some calculus and linear equations? So is mathematics this human construct that is of something of our own invention, or is there something deep and seminal about mathematics here? So let's have a look at these numbers, and what I want to look at is these two broad philosophical questions to sort of spark some controversy tonight for the end of the night. So numbers, those of you who have anxiety late at night like I do, watch HGTV a bit too much because it just sort of really puts you on the right wavelength about people thinking about their backsplashes and their marble countertops that they're possibly can't live without and going to have to replace in that new kitchen. So, tiling the backsplash, and you might have this as your mitre 10 Saturday afternoon project, and you think, right, I'm just measuring this, I'm going to need 7 tiles across here and 5 tiles across here, 5 times 7, 35, and then you diligently go to mitre 10 and you buy your 35 tiles, and lo and behold, that backsplash fits in exactly 35 tiles. It's like, how is it mathematics gets it so right all the time? What is so incredible about mathematics? Because not only if it's tiling the backsplash, but if you're trying to figure out how much you need to charge your EV to get to Queenstown or put a rocket to the moon or other such things that we need numbers for, mathematics, as long as you put in the right data, always seems to get things right. How is that? So the idea that how is it that mathematics comes to be so informative, it's absolutely incredible. So the idea that mathematics is true by sort of a convention, that is, that teacher back when you were 6 told you 5 times 7 is 35 and you put that in your brain, or at least that's what your cell phone or your calculator tells you now, is known as conventionalism. And there are some detractors. So some of you will be thinking, hold on a minute, Clemency, this isn't feeling right. You're just saying me I'm rote learning 5 times 7 is 35. It could be blob times bleeb equals bloopy. It's just words. There's linguistic things that we've all memorised and collectively agreed upon 5 times 7 equals 35. And so this is the philosophical school that says, actually, mathematics is just trivially true, right? It's just because we've all agreed upon shit, and that's how we need to know that. So it's called conventionalism. So just like we might say, this handsome stallion here, a male horse is a stallion, is pretty trivially true, right? You can use stallion, you can use male horse interchangeably, so too 5 times 7 or 35, we can use those interchangeably. Some of you will be thinking, hold on a minute, 5 times 7, 35, really, are those really just interchangeable and exactly the same thing? So you'd be scratching your head and perhaps saying, I might not be such a conventionalist after all. So is mathematics made true by the conventional things that we agree upon, or is it made true by something, appeal to something more deeper? And that's where on the other side of the spectrum we get what we call mathematical realism. And mathematical realists say, actually, mathematics is made true by mathematical facts. Okay, so we can go out and 5 times 7 equals 35 is a mathematical fact. So maths are made true not by convention, but actually facts. And so the critics might say, well, actually, where do you find these facts? So you say, well, astronomers have astronomy facts, and chemists have astronomy facts, so mathematicians have mathematical facts. So the objection to realism, while it seems quite interesting, is where are these mathematical facts, right? Okay, astronomy, you can look at the sky, you can look at the stars, chemistry, you can mix test tubes. Numbers? Show me some numbers, okay? Show me this 5 times 7 equals 35. Where is these numbers existing apart from my backsplash or otherwise? So realism seems to be quite appealing at first. And of course, as I see, there's a few of my technical colleagues in the audience. You know, mathematicians don't like to think they're just sitting around doing stuff that they've made up all day, all right? That they're actually appealing to something that's real and exists and is eternal knowledge that helps us figure out things. And there's a sense in which mathematics just seems to be incredibly right. It does tell us how to put a spaceship on the moon. It does help us figure out how long our EV is going to last. So there's something very compelling about realism, but where are these mathematical facts? And this is where we call the strange realm of numbers, wherever that is. So how do we get to know about this strange realm of numbers? And so one of the arguments is, of course, just like astronomers use their eyes and a telescope to look at the stars, just like chemists might smell things or the like, or otherwise, can our senses confirm our mathematical claims? And so this is an interesting one, right? So you might count those tile on your backsplash. So mathematics, we can use our eyes to count things, but is it reliable and is it always informative? And what about those things that we have no experience of? Like if I add, 1,362,000, which you might never have had experience of that actual number, by another number, you say, actually, I haven't experienced that before. I've never seen that many people or kitchen tiles or the like. So there's something very special about mathematical knowledge which doesn't appeal to our senses. And also, there's another argument which I'm lovingly called in the New Zealand theme, the possum argument. So maybe we can say, okay, we've got, you go off to the bar and you buy 2 drinks, and then your friend buys 2 drinks and you've got 4 drinks. So 2 plus 2 equals 4. I've just experienced that. But suppose we're dealing with 2 male possums and 2 female possums, and we leave them in the bar for a few weeks, and what do you expect to find? So how does mathematics cope with that? Are our senses always infallible, or will our senses actually tell us that 2 plus 2 equals 4, or is there something else going on? This is when Plato comes in. So this strange realm of numbers, we need these numbers, we see them all around ourselves, they're really useful for us. How do we have access? And this is where Plato, one of the world's first philosophers in ancient Greece, comes about and has this brainy idea around how we have access to, and he calls this Platonic intuition. And I suspect my mathematical colleagues, whether they know it or not, are closet Platonists, because, again, it gives meaning to this idea that mathematics actually appeals to some amazing realm, the strange realm of numbers, of shapes, of concepts, like even and odd and symmetrical things, and actually our brain somehow neurologically connects with this. So we all agree upon what a circle is, right? And we might see that light there, which sort of looks circular in shape, but it's not a perfect circle, right? We might look at my cup and say, I can see a circle there, but it's not a perfect circle. So Plato would say, all of us have this idea of a perfect circle, which only exists in the strange realm of circles. And the only thing that we have are these approximations, which we've all have access to be able to identify circles. So he had and I don't have, but if you do want to go and read some philosophy on a rainy Wednesday night, then Plato's Meno, which he explores this idea of how we come to find mathematical knowledge in the first place, is really cool. And in fact, it's a dialogue between sort of an ancient Greek anti-hero called Socrates, who's always known for being a rather irritating character, and a slave boy. And in fact, Socrates, there's a very famous, so Plato didn't write philosophy straight. He wrote it in the form of almost plays or dialogues, which is really why it's quite fun to read. Sort of a level of suspension of disbelief, I think, before claiming beyond that. So Socrates was always Plato's spokesperson to be able to convey his views. Socrates is irritating because he has these conversations with people and just shows them that they don't know what they thought they knew, hence the irritation. And so what he does with this particular dialogue, in which there are three characters, Socrates, the slave boy, and Meno, who's an Athenian statesman, and he wants to prove to Meno that, in fact, this slave boy, and the slave bit is important, this is ancient Greece after all, has no formal education, but Socrates very carefully guides him through this particular problem. So some of you can see, if you can explain it to your flatmates or housemates or spouses, that if you get a square, what is the square that is double the area of the original square? All right? And Socrates shows, and this is the kicker, that without teaching the slave boy anything, he will get the slave to prove this mathematical relationship, and he's had no formal training. So the point Socrates is trying to make is that actually we're all deeply mathematical. You too can go into a bar and say, I'm a mathematician, and wait for the silence. And really, that mathematical knowledge is a form of recollection in our soul. I mean, Plato gets a bit spacey towards the end of this dialogue and starts saying things about recollection in the soul. But he basically very cleverly, and there's a bit of contention around here whether Socrates is actually teaching the slave boy anything. But I'll just give you a wee teaser. Now, boy, he says, just let me get a bit closer. The square is a figure like this. Boy, yes. Boy doesn't have much of a feature in this dialogue. Socrates says, such a figure could be either larger or smaller, could it not? Boy, yes. Socrates is going to get rather irritating. And so Socrates goes through and says, what's the area of this particular square? And the slave boy says 4. And Socrates says, now we could draw another figure double the size of this, but similar. That is, with all its sides equal to this one. So he's just leading the slave boy, and don't have time now, but it goes on. And first of all, the boy comes up with a square, which is 4 times the area, right? And so he says, and Socrates shows him that that's not right. And then the slave boy comes up next with a diagram that is has a side length of 3, which Socrates shows is not right. And then there's the aha moment when, here's this sort of spoiler alert, and that in fact, if you take that original square there, I've got a pointer on here, oh yes, so this original square here, A, B, C, D, and if you in fact take the diagonals there and draw a square on that diagonal, you will have a square that's the original, double the original size of that A, B, C, D. And you can just see, look, each side, of course, is half of, you've essentially cut the original square in half and then you're adding it, so you've got double. And so whether or not Socrates is actually teaching the slave boy is one thing, but Socrates says he is not. So in fact, For Plato, access to the strange realm of numbers is actually through a process of recollection of something that's transcendent to all of us, something that's in our soul, and something that really gets him off into this weird transcendent rant about the immortality of the soul. There's philosophy for you. So let's pull it back from immortality, the soul, to this idea about, is mathematics invented, therefore, or discovered? And in fact, some think, okay, it's invented, right? Because, we just came up with numbers and maybe we could call them differently, or we recognise circles and things, but maybe aliens, if they came, would call it squircles. And gosh, if aliens really looked at the area of a circle, would it still be pi r squared, or it would be pi r smeared or something? I don't know. And so is there a sense in which mathematics is invented by a collective agency, or is it discovered? Okay, are we gradually and patiently working through history and uncovering these mathematical truths that get more and more complicated and rich and allow us to do better and better things like build LLM models and the like? So is mathematics invented or discovered? Both have some fairly anxiety-producing implications if you start thinking. For those who think mathematics is invented, it's just a human construct, then what are mathematicians actually doing? They're just making up games and board games like Scrabble and Monopoly. And the critics will say to those, well, how come mathematics is so damn useful if you're just inventing it? Why is it so incredibly good at predicting stuff that's going to happen in the world? But there's a sense in which when you say mathematics is discovered, it's like, well, maths existed when the dinosaurs were there, and we're just sort of going through in history and uncovering bits. And so the mathematics we have today is much better than it was 100 years ago, and it will be even better in 100 years. Will we get to the end of mathematics, okay? Or will we just invent some more? So there's both really interesting debates to be had around there, and you can ping me in the question section if you're feeling particularly aggravated by either or position. But I want to leave you now, rather than being aggravated by the philosophy of maths, but actually move it on to the question of love and our affection for numbers. Some of you will be familiar with the very famous journalist Alex Bellos, who writes lots of things, particularly about Brazilian football, but also gets into mathematics, and wrote this famous book called The Grapes of Math. Alex was really interested by our both perceived phobia of numbers, the scary stuff around numbers, but also that we kind of have a deep affection for them. So what do we do when we want to find out what people think? We send out a survey and use mathematics to analyse the results. So he sent out the survey, and to his absolute delight and surprise, within a few days got 30,000 responses for various people across the UK. And the survey basically said, what's your favourite number and why? You can bring that up in the questions section, right? And so he said, I had not realised the depth of our collective number love. So bringing it away from the scary stuff back to number love. However, until I conducted an online experiment asking members of the public to nominate their favourite numbers. I know you're thinking of it right now. Okay, and explain their choices. I was taken aback not only by the level of interest, more than 30,000 people took part in the first few weeks. 2, because the respondent has 2 piercings. 6, because the 6th track on the respondent's favourite album is always the best song. 7.07, since the respondent used to wake up at 7 minutes past 7, and once her shopping added up to $7.07 in front of the cute cashier at the local shop. 17, because that's how many minutes the respondent takes to cook rice. I mean, he was just overwhelmed. People had love for numbers and reasons as to why, and were ready to expound them. 4, because her boyfriend sleeps like 2 on his side. Okay? Having a favourite number means you get that little buzz every time you happen to be sitting in a seat, 53 on a train, or notice that the time is 9:53, wrote one respondent. I can't think of a reason not to have a favourite number. So, I'll leave it with that. Turn it from the scary to the beloved. What's your favourite number? Thank you very much.
Oh, thank you very much. Do we have any questions?
Awesome. Favourite numbers with your reasons. So the question is, do I think numbers are invented or discovered? Part of this role is just actually trying to problematize the very question itself, right? So there's a problem with philosophers is they love to raise these ethical or philosophical or metaphysical dilemmas and then fight about the answers. I think if really hard pushed, and some of my mathematical colleagues might start chuckling, that there is meaning to what I do which transcends my humanness. So on the invented versus discovered, I think I would have to be towards the discovered side. Problems arise may be them. What about you? Agree.
Do you think Socrates taught the slave boy?
So there's one point where the answer was, in fact, you find what they call the diagonal on the square, and the scary technical mathematical term for that is hypotenuse, bring you back to fifth form mathematics. Socrates tells that to the slave boy in the dialogue. So everybody goes, he's teaching the slave something. You don't really need to know that the diagonals is the hypotenuse. I think it's a really interesting question. Socrates is asking some very leading questions. He's, saying, and 3 times 3 is 9, isn't it? Right? And so there's a rhetorical questions. I would say that it's proving an interesting point, but definitely Socrates is leading the boy exactly where he wants to. But it leads us to an interesting point. There's sort of a thought experiment, and I emphasise the thought that philosophers have about the baby in the box. No babies were harmed in this thought experiment. That if you put a baby in a cardboard box the second they were born and, taped it all shut, and the baby had lived the lifetime of the universe, it's getting more and more unrealistic, that would the baby come up with maths if they had enough time, right? Without any sensory input, not only from their own senses, but anybody talking to them. If they stayed there long enough, would they come up with maths on their own? And that pertains in interesting ways to, do we need to be taught these things, or the idea of recollection? Would the baby in turn be able to recollect these things with prompting? Philosophers, get really irritating, don't they? It's a great question.
Do we know any animals that use math?
That's a fascinating question. So maybe some psychologists in the audience want to jump in. When we look at the concept of zero, there's some evidence that psychologists they've done some experiments about, can animals recognise the difference between 0, 1 and many, or just some really broad number concepts. Experimental design is interesting. I haven't read too much into it, but if you put in front of a monkey no bananas and then an area with 1 banana and 50 bananas, and the monkey goes towards the 50 bananas, is that understanding the concept of quantity, or is there a way in which you can design monkeys to go to nowhere, to the one with none? So do animals understand quantity? I think probably. Another related interesting question is, for those some of those oral cultures of inquiry that don't have a symbolic representation for numbers, or may not even have words for numbers beyond nothing, 1 and many, what is the sophistication of the arithmetic systems that they have? And what's really interesting is the higher you get, of course, the less good the arithmetic system get, but you do have a general level of numeracy even without the language to express it. And there's some really interesting experiments that you can do to try and look at that. Yeah, it's a fantastic question. Come on, somebody must have a favourite number.
What's your favourite number and why?
I just thought somebody's going to ask me what my favourite number is, right? Goodness. I'm going to say the number 0. The number 0. And we'll leave it at that. Thanks, everybody.